Hey everyone, and welcome to another deep dive. Today we're going to be taking a look at NoSQL databases.
All right.
Yeah. So, imagine you've got this app and it's like really taking off, right? Users are flooding in, data's coming in faster than you can handle it.
Oh, yeah.
That's where NoSQL comes in, right?
Yeah.
It's kind of the secret weapon behind all those, like super smooth and scalable apps that we all use every day.
That's right.
Like, sometimes like you're using your favorite app and like when a ton of people are using it, it gets like kind of slow and laggy.
Oh, yeah.
NoSQL is designed to like prevent that.
For sure.
So today we've got some really fascinating insights that we're going to be pulling from FalkorDB, which is kind of a big deal in the NoSQL world. And we're also going to be unpacking this recent article that like really breaks down the essentials of NoSQL.
Yeah, sounds good.
And get this right, FalkorDB uses some like pretty serious math stuff, like a sparse matrix representations to make those LLMs, the large language models everyone's talking about,
Yeah.
way more accurate, which is a huge deal for all of us because it means that, like the AI models that we're all interacting with are going to be like way less prone to errors and will be able to, give us more reliable information.
That's really cool.
So before we get into all that, like, let's take a step back. Okay.
So,
What is NoSQL and like, why is it such a big deal?
what's interesting here is that NoSQL represents like a fundamental shift in how we think about databases.
Yeah.
Think of traditional relational databases as like meticulously organized filing cabinets, right?
Uh-huh.
They're perfect for structured data that fits neatly into like rows and columns.
Okay.
But when you're dealing with these massive, ever-changing data streams that modern applications generate, those cabinets start to overflow.
Right.
NoSQL is like having adaptable containers that can like expand and morph as needed. It's built for speed and flexibility. It's built to handle, this like explosion of data that modern apps generate. We're talking about a challenge like scaling up across multiple servers, dealing with data that doesn't fit neatly into those rows and columns, and processing information in real time.
Right.
NoSQL tackles these head on.
Okay, so NoSQL is all about adapting to like the wild world of modern data, right?
Yeah.
The article we're looking at, it highlights some key characteristics like schema flexibility, horizontal scalability, high availability, focus on big data support for diverse data models. Could you unpack a few of those for us?
Absolutely. Let's start with schema flexibility.
Okay.
Imagine you're adding like a new feature to your app.
Uh-huh.
With NoSQL, you can easily accommodate that new data without like redesigning your entire database.
Okay.
It's like having a database that can evolve as your app does, which is vital in a fast-paced development environment.
That's interesting, but like how does that compare to like traditional relational databases in terms of like data integrity?
Yeah.
Don't you need like some structure to like make sure everything stays consistent?
You're right to raise that point. While NoSQL offers greater flexibility, it does require careful consideration of data consistency.
Okay.
But rest assured, there are mechanisms in place to ensure data integrity.
Okay.
We'll dive into those a bit later.
Okay, good to know.
Yeah.
Now, what about horizontal scalability?
Right.
I hear that term thrown around a lot, but I'm not entirely sure what it means in practice.
Think of it like this. As your user base grows, you need your database to keep up without breaking a sweat.
Yeah.
Horizontal scalability means that you can distribute your data across multiple servers, so no single machine becomes a bottleneck.
Oh.
It's like having a team of servers working together to handle the load, ensure your app stays responsive, even during like peak traffic times.
Ah, so it's like having a distributed workforce for your data.
Exactly.
That makes a lot of sense. Now, the article also mentioned something called high availability.
Right.
What is that all about?
High availability is all about ensuring that your app stays up and running, even if part of the system fails.
Okay.
Think about those times when like a website is down.
That's usually due to a lack of high availability.
Right.
NoSQL databases are designed with redundancy in mind. So if one server goes offline, another one can seamlessly take over.
Oh.
It's like having a backup generator for your data center, making sure the party never stops.
So we've got this super flexible, scalable, and resilient database system.
Yeah.
But I have to admit, I'm starting to get a little lost in the technical jargon. Can we like get a peek under the hood and see what's actually going on inside a NoSQL database?
Absolutely. Let's start with storage engines.
Okay.
These are like the heart of the system, dictating how data is stored and retrieved.
Okay.
Some NoSQL databases use structures like LSM trees, which are great for handling lots of writes. perfect for apps that are constantly generating new data.
Hmm.
Others use B trees optimized for fast lookups, essential for quick data retrieval.
Okay.
Think of it like choosing the right type of filing system for your needs.
Right.
Some are better for archiving lots of documents, while others are designed for quick access to specific files. Okay, so it's about choosing the right tool for the job.
Exactly.
What about the data models themselves?
Yeah.
The article mentions document stores, graph databases, key value stores.
Right.
It's starting to feel like a buffet of data options.
And that's a good thing.
Okay.
NoSQL offers a variety of data models, each suited to different tasks.
Okay.
Document stores are great for flexible JSON-like data, perfect for rapid development and evolving schemas.
Uh-huh.
Imagine storing user profiles with all sorts of information,
Okay.
text, numbers, images,
Hmm.
even nested objects,
Hmm.
all in a single, easily manageable document.
Okay.
That's the power of a document store.
So it's like having a digital container that can hold all sorts of different items
Yeah.
without needing to like predefine the exact structure.
Exactly.
That's pretty cool. What about graph databases?
Right.
Those sound intriguing.
Graph databases are fascinating. They excel at representing relationships between data points.
Okay.
Imagine a social network where you want to map out who follows who, or a recommendation engine that connects users to products they might like.
Yeah.
Graph databases make those connections explicit, allowing for incredibly powerful and efficient queries.
That makes sense. And what about those speedy key value stores? What are they best suited for?
Key value stores are the simplest and often the fastest type of NoSQL database.
Okay.
Imagine a giant dictionary where you can quickly look up values based on their keys.
Ah.
They're perfect for things like caching frequently accessed data or managing user sessions.
Okay, so we've got this incredible toolkit of different NoSQL databases, each with its own strength and use cases.
Mhm.
Now, the article mentions FalkorDB as like a standout example of a modern NoSQL database.
Yeah.
What makes it so special?
FalkorDB is doing some really innovative things,
Mm-hmm.
particularly in how it leverages distributed storage and data partitioning.
Okay.
Remember how we talked about horizontal scalability,
Yeah.
spreading data across multiple servers?
Yeah.
FalkorDB takes this to heart, automatically distributing your data across multiple nodes,
Mm-hmm.
ensuring that no single point of failure can bring the whole system down.
So it's like having a self-healing database system.
Right.
If one part goes down, the rest can keep running smoothly.
That's right.
That's impressive. But what about like the actual process of working with the data?
Yeah.
How does FalkorDB handle things like querying and indexing?
FalkorDB excels at query processing and indexing.
Okay.
It uses techniques like secondary indexing and imperialized views to speed up data retrieval.
Mhm.
Imagine searching through millions of records in a snap.
Wow,
That's the kind of power we're talking about.
that's amazing.
And remember how we talked about those complex relationships that graph databases are so good at handling?
Yeah.
FalkorDB makes it incredibly easy to query those relationships,
Okay.
providing insights that would be incredibly difficult to extract from a traditional database.
That sounds incredibly powerful. Can you give us a real-world example of how all this like technical wizardry translates into something we can understand?
Let's say you're building a social media platform. You need to store user profiles, their posts, who they follow, and all the interactions happening in real time.
Mm-hmm.
A traditional database would struggle with this massive and constantly changing web of data.
Yeah.
FalkorDB, being a graph database, can map those relationships directly and efficiently.
Okay.
It can quickly retrieve data like show me all the posts from people followed by Alice who also like cats.
Wow.
This kind of query, which would cripple a relational database, is a breeze for FalkorDB, thanks to its graph-based approach.
Now that we've explored the basics and seen how these concepts come to life with like a real-world example using FalkorDB,
Yeah.
let's get our hands dirty and see how to actually build a system with FalkorDB.
Right.
What are the key takeaways for someone just starting out with this technology?
Setting up FalkorDB is surprisingly straightforward.
Okay.
You can spin up an instance using Docker, a popular containerization technology, with just a single command.
Wow.
Then, using their Python client, you can connect to the database and start working with it.
Wait, hold on, Python client. Does that mean you need to be like a coding whiz to use FalkorDB?
Not at all.
Okay.
FalkorDB is designed to be user-friendly, even for those who aren't hardcore programmers.
Oh, okay.
The Python client provides an intuitive way to interact with the database, insert data, and run queries.
So it's like having a friendly guide to help you navigate the world of NoSQL.
Exactly.
Now let's walk through this building process a bit.
Sure.
What are the steps involved in creating a basic NoSQL system with FalkorDB?
The first step after setting up your Docker container is to insert some sample data.
Okay.
Remember how we talked about schema flexibility?
Yeah.
Well, FalkorDB lets you store data in JSON-like structures, which are incredibly versatile.
Okay.
You can include all sorts of information from simple text to complex nested objects without having to define a rigid schema beforehand.
It's like building with Lego blocks. You
Yeah.
can put them together in endless combinations, but
Exactly.
once you've got your data in there, how do you actually find what you need?
That's where querying comes in. FalkorDB offers a variety of ways to search through your data.
Okay.
You can perform string-based matches to find exact values, range-based matches to filter data within specific limits, and even array or list-based matches to check for values within a collection.
Oh, wow.
Let's say you want to find all users who live in New York and have Python listed as a skill. FalkorDB makes this kind of search incredibly easy, returning the results you need in an instant.
And remember how FalkorDB excels at handling relationships between data points?
Yeah.
How does that come into play when building a system?
This is where FalkorDB truly shines.
Okay.
It lets you query those relationships directly, providing insights that would be incredibly difficult to extract from a traditional database.
Okay.
For instance, you could easily find all companies that sponsor events attended by people who work in a specific industry.
Wow.
The possibilities are endless.
Okay, so far we've gone from the basics of NoSQL to actually building a simple system with FalkorDB. But before we dive into the nitty-gritty of scaling and clustering, let's take a pause here for part 1 of our deep dive. Hashtag TTS, the deep dive episode 2025-0311, part 2 of 3. Welcome back to our deep dive into NoSQL databases. Last time we left off talking about building a simple system with FalkorDB.
Right.
Now let's crank things up a notch and explore how to create a FalkorDB cluster for ultimate scalability.
Okay.
You know how some apps can handle like millions of users without breaking a sweat?
Uh-huh.
Well, clustering is a big part of that magic.
Exactly. Remember how we talked about horizontal scalability?
Yeah.
Spreading data across multiple servers.
Mm-hmm.
Clustering takes that concept to the next level. It's like creating a team of servers,
Okay.
each handling a portion of the data and working together to keep your app running smoothly no matter how much traffic comes your way.
So it's like building a data center with superpowers.
Yeah.
How do you actually go about creating a FalkorDB cluster? Where do we even begin?
First, you need to set up a network specifically for your cluster. Think of it as laying the foundation for communication between all the nodes in your system.
Okay.
Docker makes this super easy. With a simple command, you can create a dedicated Docker network, like building a private highway, just for your data.
Okay, so we've got our network, our data highway.
Right.
What's next? Do we just start adding FalkorDB nodes like cars on the road?
Not quite. We need to configure each node to work harmoniously within the cluster.
Okay.
When you launch your first FalkorDB node, you'll use specific commands to enable cluster mode and point it to a configuration file. This file is like a set of rules that outlines how the nodes will communicate and share information.
It's like giving each node a driver's manual for the cluster highway.
Right.
And I'm guessing we repeat this process for each additional node we add.
Precisely. But here's where it gets interesting connecting the nodes.
Okay.
You'll need to retrieve the internal IP address of each node within the Docker network, and then use a special command cluster meet to introduce them to each other. It's like setting up a meet and greet for your database nodes.
I can already picture them exchanging virtual handshakes and data packets.
Yeah.
But how do we know if our cluster is actually working as intended?
Right.
Are there any warning lights we should be looking out for?
FalkorDB provides a handy command cluster info, which gives you a status update.
Okay.
If everything is running smoothly, you'll see a comforting clusterstate.ok message.
That's good.
You can also use cluster nodes to list all the connected nodes, confirming that everyone is playing nicely together.
So we've built our cluster. Our nodes are chatting, data is flowing.
Yeah.
It feels like we've created a data party.
Right.
But what happens when that party gets a bit too crowded? How do we make sure our cluster can handle the influx of guests as our app grows?
That's where FalkorDB's auto-sharding comes into play.
Okay.
It's like having a magical bouncer at your data party, automatically directing traffic and balancing the load across all the nodes. As new nodes join the cluster, FalkorDB intelligently redistributes data partitions, ensuring that no single node gets overwhelmed. Think of it as dynamically resizing the dance floor to accommodate more partygoers.
It's like a self-organizing data ecosystem.
Exactly.
But beyond just handling the influx of data, what about keeping the party going even when things go wrong? How does FalkorDB ensure high availability and fault tolerance? what if someone spills their drink on a server?
FalkorDB is built for resilience. It has automatic failover,
Yeah.
meaning that if one node decides to take an unexpected break or gets splashed with a beverage, a replica node is instantly promoted to keep the party going without interruption.
So it's like having an understudy ready to step in at a moment's notice. I'm
Exactly.
sensing a theatrical theme emerging here.
And the show must go on
Right.
to prevent data loss. FalkorDB's persistence engine periodically saves snapshots, like capturing the highlights of the party for posterity. And if a hardware issue arises, FalkorDB gracefully shifts workloads to healthy nodes, no manual intervention required. It's like having a stage crew ready to handle any unexpected mishap.
It sounds like FalkorDB is the ultimate party planner, always prepared for the unexpected.
That's right.
But with all this dynamic scaling and failover magic happening, how does FalkorDB ensure data consistency across all these nodes? Wouldn't spreading data around potentially lead to conflicts or mismatches? Imagine two guests trying to update the same RSVP at the same time. Chaos?
That's a great point. FalkorDB tackles data consistency through a clever combination of replication and carefully chosen consistency models.
Okay.
Replication means that data is copied across multiple nodes, ensuring redundancy and reducing the risk of data loss. It's like having multiple copies of the guest list just in case someone spills punch on one of them.
Okay, that makes sense. But what about those consistency models you mentioned? How do they help prevent those RSVP conflicts?
Consistency models offer flexibility to suit different application needs. You can choose between strong consistency, where every read reflects the most recent write, or eventual consistency, where updates are propagated, gradually prioritizing speed and availability.
Okay.
Imagine strong consistency as making sure everyone sees the updated RSVP instantly, while eventual consistency is like allowing a short delay before the updated list is reflected everywhere.
So it's about striking the right balance between keeping the guest list perfectly synchronized and making sure the party keeps flowing smoothly.
Exactly.
Now, I'm curious, are there any specific settings or parameters we can tweak to fine-tune our FalkorDB cluster for peak performance? Can we optimize the music playlist or adjust the lighting to create the perfect ambiance?
Absolutely. FalkorDB gives you granular control over key performance levers.
Okay.
You can adjust the thread count to allocate CPU resources, strategically matching the demands of your workload. Similarly, you can fine-tune the cache size to optimize memory usage, especially for frequently accessed queries. It's like having a control panel to fine-tune the party atmosphere and make sure everyone has a great time.
So it's not just about setting up the cluster, but also about ongoing optimization and fine-tuning to ensure everything runs like a well-oiled machine or perhaps a well-choreographed dance routine, given our party analogy.
Exactly. And that's what makes building a system with FalkorDB so exciting. It's not just about storing data. It's about creating a dynamic, resilient, and high-performing environment where your app can thrive.
I'm ready to put on my dancing shoes, but before we get too carried away with our data party, let's take a pause here for part 2 of our deep dive. Hashtag TTS, the deep dive, episode 2025-0311, part 3 of 3.
All right, welcome back to the final part of our NoSQL deep dive. We've gone from the basics of NoSQL to actually building a scalable system in the FalkorDB, even throwing in a little bit of a data party along the way.
It's been quite the journey.
Yeah, it really has. But before we wrap up, let's zoom out a little bit and look at the bigger picture, right? We've been kind of singing NoSQL's praises this whole time, but it's not a magic solution for every single data challenge, is it? There must be some trade-offs to consider. That's an important point. Any technology, NoSQL has its strengths and weaknesses,
Okay.
Understanding these helps you make the right choice for your application. And actually, the article that we've been looking at addresses this directly
Oh, perfect.
with some FAQs.
Awesome. Let's tackle those FAQs. The first one is about data consistency in a distributed system.
Right.
We talked about replication earlier, but I'm still a little fuzzy on how NoSQL ensures that all those nodes stay in sync, especially when things are changing super rapidly.
It's all about those tunable consistency models we mentioned earlier.
Okay.
It's kind of a fancy way of saying you can choose the level of strictness you need for your data. If your app demands absolute consistency, like where every single user sees the exact same data at the same time, you can configure that. It might have a small impact on performance, but it guarantees that everyone's on the same page.
Okay, so it's like choosing between a perfectly synchronized dance routine where everyone hits their mark at the exact same time, or a more free-flowing jam session where there's a little bit more room for improvisation.
Exactly. And for many applications like social media feeds or product recommendations, that looser, more improvisational approach, which is eventual consistency, is totally fine.
Right.
It means updates might take a tiny bit longer to go across all the nodes,
Hmm.
but it keeps the system super fast and responsive after all. Who wants to wait like forever for their feed to refresh?
You're right. I'd rather have a slightly delayed feed than like a super slow app.
Exactly.
Okay, let's move on to the next FAQ, which is diving into the technical differences between all these various NoSQL architectures.
Okay.
We've talked about document stores, graph databases, key value stores, column family stores. Like,
And
how do you know which one to pick? It's like standing in front of a dessert buffet and just being overwhelmed by all the delicious options.
it really is. And it's all about picking the right tool for the job, like we were saying earlier.
Yeah.
Document stores, remember those flexible containers we talked about?
Yeah.
They're really good at handling data that's constantly changing and doesn't fit neatly into predefined categories.
Hmm.
Think of a product catalog where you might need to add new attributes or variations like all the time.
Okay.
Document stores are awesome for that kind of flexibility.
So if you need a database that can like adapt as quickly as your product line changes, a document store might be the way to go.
Yeah.
What about graph databases? When are those the best choice?
Graph databases are all about relationships.
Hmm.
You know,
Hmm.
those connections between different data points that reveal like hidden patterns and insights.
Right.
They're perfect for social networks, recommendation engines,
Hmm.
fraud detection systems. Anything where understanding those connections is super crucial.
Okay.
Remember our social media example earlier?
Yeah.
A graph database could easily uncover these complex relationships. Like, users who follow this influencer also tend to buy these products.
Right.
That's really valuable information.
Yeah, it's like having a detective on your data team,
For sure.
uncovering those hidden connections that would have otherwise gone totally unnoticed.
Totally.
Now, what about key value stores? What are their like superpowers?
Key value stores are the speed demons of the NoSQL world.
Okay.
Think of them as like a giant, super fast lookup table.
Uh-huh.
They're great for caching frequently accessed data like those product recommendations we keep talking about,
Right.
or for managing user sessions, making sure your login stays active even as you browse different pages.
Okay, so if speed is your top priority, a key value store might be just what you need.
Exactly.
Now, we haven't talked too much about column family stores. What's their specialty?
Column family stores are a bit more specialized,
Okay.
but they're super powerful for analytical workloads where you're like slicing and dicing massive data sets to uncover trends and patterns.
Mm-hmm.
Imagine analyzing customer purchase history to identify like popular products or like seasonal buying behaviors.
Okay.
Column family stores are optimized for that kind of large-scale data crunching.
So we've got this amazing array of NoSQL options, each with its own strengths and use cases.
Right.
But like the million-dollar question remains, when should developers like ditch their trusty relational databases and go all in on NoSQL?
Right.
Is it a complete replacement or is it more of a complementary tool?
It really depends on your needs.
Yeah.
You know,
Yeah.
if you're dealing with massive volumes of data that's unstructured,
Hmm.
if you need to scale rapidly,
Right.
or your application demands super high velocity operations, NoSQL starts to make a lot of sense.
Okay.
Think like real-time analytics, social networks, content delivery systems, IoT, sensor data. These are all like prime candidates for NoSQL solutions.
So if you're building like the next big social media platform or creating a system to analyze sensor data from like a fleet of self-driving cars,
Yeah.
NoSQL might be the way to go.
It might be.
But what about those cases where like a traditional relational database still makes sense?
Absolutely. If you're working with data that's highly structured,
Okay.
if you require really strict transactional integrity,
Right.
and your data model fits nicely into that relational paradigm,
Mm.
sticking with an RDBMS might be the best choice.
Okay.
Think about things like financial transactions or inventory management systems where accuracy and consistency are super important.
So it's like choosing between a Swiss Army knife and a scalpel.
Yeah.
Both are incredibly useful tools, but they're designed for different purposes.
Exactly.
And like what's so cool is that as technology keeps evolving, we're going to see even more innovative approaches to data management emerge.
Absolutely. The lines between NoSQL and relational databases are getting blurrier
Right.
with these hybrid solutions combining like the best of both worlds.
Yeah.
And with the rise of AI and machine learning, we're going to need databases that can handle these increasingly complex data relationships
Right.
and can give us insights in real time.
Mm-hmm.
The future of data management is all about flexibility, scalability, and intelligence.
And that's what makes this field So fascinating. It's constantly evolving, pushing the boundaries of what's possible with data. I mean, we've covered so much in this deep dive,
Yeah.
from like the fundamental concepts of NoSQL to the steps you need to take to build a system with FalkorDB. We've explored the trade-offs, compared different architectures,
Hmm.
and even talked about the future of data management.
There's been a lot.
Yeah, it has. I'd like to leave our listeners with a final thought to ponder, though. As we generate more and more data at an ever-increasing pace, how will NoSQL databases evolve to meet these challenges?
That's a great question.
Right. How will they shape like the apps we use every day, from personalized recommendations to groundbreaking scientific discoveries? The possibilities are endless.
They really are.
And if you want to learn more about FalkorDB, check out their website. They've got detailed documentation resources for developers and even a free trial to get you started. Thanks for joining us on this deep dive into the world of NoSQL.
Okay, Zero.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with data.